Welcome back, TechBusters. Get ready to conduct the Symphony of Python, where operators are the instruments that bring your code to life. In today's episode, we're exploring the magical world of Python operators. Think of them as the conductors in an orchestra, each guiding your data to create a melodious program. Let's tune our instruments and make some coding music. All right, let's get up close and personal with Python's arithmetic operators. These are the basic tools in Python that let us perform mathematical operations with ease and flair. Let's break them down one by one. First in line is the addition operator, the friendly plus. It does exactly what you expect, adds numbers together. For instance, if you're counting apples, 2 plus 3 would give you 5. Simple, right? In Python, you'd write add underscore apples =, 2 plus 3 print. Add apples. Next, we have subtraction, symbolized by the dash. It helps you find the difference between numbers. Let's say you started with 5 apples, and you gave away 2. You'd calculate this as 5, 2, leaving you with 3 apples. In Python, it looks like this. Sub underscore apples =, 5, 2 print, sub apples. Ready for more? Here comes multiplication, the asterisk operator. It's like growing your fruits exponentially in a magical garden. If one tree gives you 3 apples, and you have 4 trees, you'll have 3 asterisk 4 apples, which is 12. See it in action. Mule underscore apples =, 3 asterisk 4 print, mule apples. Now let's divide and conquer with the division operator. If you have 10 apples and want to share them equally among 2 friends, you'd use 10 halves. This splits your apples evenly, giving 5 to each friend. Here's how Python does it. Div underscore apples =, 10 halves print, div apples. Ever wonder how to find the remainder in Python? That's where the modulus operator % shines. It tells you what's left after division. For example, dividing 10 apples among 3 friends, 10% 3 leaves 1 apple unshared. Let's look at the code. Mod underscore apples =, 10% 3 print, mod apples. Feeling powerful? The exponentiation operator *** raises a number to the power of another. It's like multiplying a number by itself several times. For instance, 2 ** 3 is 2 multiplied by itself 3 times, resulting in 8. In Python, it's as easy as exp underscore apples = 2 ** 3 print, exp apples. Lastly, meet the floor division operator //. It divides and rounds down to the nearest whole number. When you divide 10 apples among 3 friends, 10/3 will give each friend 3 apples, with 1 left over. Python does it like this. fdiv underscore apples = 10/3 print, fdiv apples. Now let's step into the realm of comparison operators in Python. These operators are like the decision makers in your code, helping you compare values and make logical deductions. They're essential in guiding the flow of your program based on conditions. We'll explore each of these operators and see them in action. First up, we have the =to operator, =. It checks if 2 values are the same. For instance, comparing if 5 is equal to 5. Next is not equal to, represented by $. This one does the opposite. It checks if 2 values are different. Let's say we want to know if 5 is not equal to 3. Moving on to greater than and g and less than and lat. These operators compare 2 numbers. If you want to see if 7 is greater than 5, you'd use and g. Conversely, to check if 3 is less than 5, you'd use an lt. Then we have greater than or equal to, and gt =, and less than or equal to, and lt =. They're similar to the previous ones but include equality. So if you're checking if 5 is greater than or equal to 4, or if 3 is less than or equal to 3, you'd use these operators. Now we will explore Python's logical operators. These operators are the masterminds behind complex decision-making in your code. They allow you to combine multiple conditions and create sophisticated logic. Let's unravel the mystery of these operators with some practical examples. First, let's meet the AND operator. It's like a strict gatekeeper that only lets you pass if both conditions are true. Imagine you want to go out, but only if it's sunny and warm. In Python, you check this like so. Is underscore sunny equal sign. True is underscore warm equal sign. True print. Can I go out? Is underscore sunny and is underscore warm. Next up is the or operator. It's more lenient, allowing you to proceed if at least one condition is true. Say you're happy to go out if it's either sunny or warm. In Python, that decision looks like this. Is underscore sunny equal sign. True is underscore warm equal sign. False print. Is it okay to go out? Is underscore sunny or is underscore warm? Finally, we have the not operator. It's the contrarian of the group, flipping the truth value of a condition. If you're not fond of rain and it's raining outside, not helps you decide to stay in. Here's how you'd express this in Python. Is underscore raining equal sign. True print. Should I stay indoors? Not is underscore raining. Next, we will get some more knowledge about assignment operators in Python, the efficient toolkit for updating your variables. These operators not only assign values, but also perform operations in the process. Let's take a closer look at how they streamline your coding experience. First off, the backbone of variable creation, the basic assignment operator equal sign. It's simple. X equal sign 5 assigns the value 5 to X. It's like saying, hey X, you're now 5. Now meet the handy plus equal sign. It adds a value to a variable and then updates it. For instance, if X is 5 and you want to add 2 to it, X plus equal sign 2 makes X now 7. It's a shortcut for X equals X plus 2. Similarly, equal sign subtracts and then updates the variable. If X is 7 and you use X, equal sign 3, it subtracts 3 from X, making it 4. It's equivalent to X equals X minus 3. Next up, asterisk equal sign and slash equal sign. The former multiplies the variable and updates it, while the latter divides and updates. Let's say X is 4. X asterisk equal sign 2 changes X to 8, and then X slash equal sign 2 brings it back to 4. Don't forget percent equal sign for modulus assignment, asterisk asterisk equal sign for exponentiation, and slash equal sign for floor division. Each updates the variable with the result of the operation. They're like the Swiss Army knife for variable updates, compact and versatile. Next will be bitwise operators. Unlike our usual operators, these work at the bit level, diving deep into the heart of your computer's binary language. They're like the digital craftsmen of Python, shaping and sculpting data right down to its binary form. Let's uncover the power of these operators. First, we have the bitwise AND operator denoted by an amp. It compares two numbers bit by bit and returns 1 for each position where both bits are 1. For example, 5 in amp, 3. In binary, 5 is 101 and 3 is 011. The only common 1 bit is in the rightmost position, so 5 in amp. 3 equals 1 next is the bitwise OR, symbolized by vertical bar. It returns 1 if at least one of the bits in a comparable position is 1. For 5 vertical bar 3, since either 5 or 3 has a 1 bit in each position, the result is 7. Then there's the XOR operator, circumflex, the rebel of the bunch. It returns 1 only if one of the bits is 1, but not both. So, for 5 circumflex 3, it looks for positions where 5 and 3 differ, which gives us 6. Finally, the shift operators, left shift and LT, and right shift and GT. These slide the bits left or right. 5 in alt and LT. 1 shifts the bits of 5 one place to the left, doubling it to 10, while 5 in jot. And got. 1 shifts 1 place to the right, halving it to 2. Next, we're exploring identity operators. These operators are all about understanding identity, not just what things are, but who they are at their core. In Python, who equates to the memory location of objects. Let's dive into the world of is and is not, and see how Python uses them to discern identity. First, we have the is operator. It checks if 2 variables refer to the same object, the same spot in memory. Imagine you have two names for your favorite teddy bear. This tells you if both names are indeed for that one beloved teddy. On the flip side is not checks if two variables refer to different objects. It's like confirming that your teddy bear and your pet cat are not the same, even if they both bring you comfort. Identity operators become particularly interesting with mutable objects like lists. If you create two lists in the same way, they may look identical but exist separately in memory. Next, we're unraveling the mysteries of membership operators. These operators are all about belonging. They help determine whether a value exists within a sequence like a list, string, or tuple. Let's delve into in and not in and see how Python uses them to confirm membership. Let's start with the in operator. It checks if a value is found in a sequence. Imagine you have a box of crayons and you're looking for a blue one. Using in is like searching through the box to find if blue is there. Conversely, not in checks if a value is not found in a sequence. Continuing with our crayon box analogy, if you're looking for purple and want to ensure it's not there, not in will give you the answer. Membership operators are particularly handy with strings. They can check if a substring exists within a larger string. Let's say you have a sentence and want to check if a specific word is part of it. Here's how it works. Sentence equals sign. The quick brown fox jumps over the lazy dog print. Is fox in the sentence? Fox in sentence. Print. Is cat not in the sentence? Cat not in sentence. And there we have it, the grand orchestra of Python operators. These tools are essential in writing efficient and effective Python scripts. They're the backbone of logic in your code, helping you make decisions, calculate results, and control the flow like a maestro.